Hello students, myself Gunjan Mittal Roy in the Department of Electronics and Communication Engineering in GEM-Tech Greater Noida. Welcome to the next video on digital communication, and the topic of my video is basics of digital communication. In the previous video we have discussed about what are analog communication signal and what are digital signals. What is the need of digitizing analog signal? What are the basic advantages of digital communication and the basic block diagram of digital communication system? Now, apart from that, we have to understand the few basic properties of digital communication system. So, in the basics, firstly, we are going to cover the different transmission mediums. In the previous video, we discussed about the block diagram of communication system, where I discussed the three basic blocks, three main blocks, which were transmitter, channel and receiver. So in the channel section, we are going to cover transmission mediums. As I mentioned in the previous video also, that there are two types of channels, one are wired and the other is wireless. So in wired there are different transmission mediums. So these are basically wired transmission mediums. First is the open wire lines. The open wire lines are the simplest copper wires, single copper wires, and they were the very first mode of transmission, and they were used in telephony and telegraphic transmission lines, and they are still in use. But the condition is that they are almost phasing out. They offer very low attenuation of the order of 0.04 decibel per kilometer. Then comes the paired wires, paired cables, where the wires are twisted. They are also called twisted wires. These are used in telephone lines for short distance communications, including buildings, local offices, etc. And they also offer very low amount of attenuation, which is approximately 0.05 dB per kilometer. Then the another transmission media is the coaxial cable, and they have a property of a cable which has a center core around which number of cables are connected, and with the insulator in between. So therefore they are named as coaxial cables. These cables offer relatively high attenuation, but they offer the transmission of the order of megahertz. The frequency band is higher compared to the open wire and paired cables, and they are mainly used in television systems, television communication, VHF or UHF communication. Then comes is the waveguide. Waveguides are hollow conductors of different shapes such as rectangular, circular or elliptical. They offer very high bandwidth, and the attenuation is also very high compared to the previous transmission modes, and it is of the order of 5 dB per kilometer. Then very effective transmission media which is used nowadays for long distance communication is optical fiber, and they are since they are made up of glass, so they offer almost all the desirable features of transmission media, such as they are not made up of matter, so they do not behave as antenna and they do not pick up the unwanted radiations. Also the cost, the thickness of the cable is also very small. They are of the order of microns. Their diameter is of the order of micrometer. So a bunch of thousands of optical fiber is equal to hardly one or two cables of simple conventional cables, or such as coaxial or simple copper wires. They are used for long distance communication. They are buried underground, and their attenuation is very low. It is of the order of 0.2 to 0.4 dB per kilometer. but they require and they offer very high bandwidth of the order of terahertz. So the bandwidth offered is mind-boggling. It is up to the order of terahertz. So after these typical transmission media, we would like to cover up the different frequency ranges. For telephone, it is 300 Hz to 3400 Hz, and so the band becomes as 34 minus 300 is 3.1 kilohertz. The coaxial cable work up to 400 megahertz, whereas the optical fiber work in the range of 10 to the power 14 to 10 to the power 15 hertz. Such a high frequency band. After that, the microwave radio channel, they offer the range of 1 to 3 gigahertz band, and the satellite channel is in the range of 0.25 to 65 gigahertz. So these are the different frequency ranges for different channels. Then we have different communication parameters. The very first parameter is signal to noise ratio. It is the ratio which defines the quality of the signal, and the mathematical expression is the amount of signal power with respect to the amount of noise power. Ideally, the signal energy or power must be high compared to the noise power. So therefore, the SNR value should always be greater than 1. In mathematics, it is expressed in dB scale, because the unit is the quantity is unitless. It is a ratio of same energy, like signal power divided by noise power, so the quantity becomes unitless. And in order to make it quantity should be made in units, so this is done by using dB scale. So the SNR in dB is 10 log base 10 signal energy upon noise energy. Now the bandwidth is the range of frequency for which a system works acceptably or good. This should be high for all the different communication techniques. The bandwidth must be as high as possible. And the next parameter is the capacity. The capacity of the channel should be to support a particular information, to support a particular form of communication. So the channel capacity should be high. This is defined by the Shannon's channel capacity theorem, where C equal to B log base 2 1 plus SNR. SNR is the signal to noise ratio, and B defines the channel bandwidth. There are two types of communication systems. One is baseband communication, other is passband communication. In the baseband communication, the signal is transmitted at low frequencies for short distances. It includes the DC level. From zero frequency the signals are transmitted. So this is called the baseband or the basic band of communication. It is used for short distances communication and for at low frequencies. Whereas the passband signals are the modulated signals, which are where band is shifted to a particular range, and this passband signals or modulated signals are used for long distance communications, and therefore they use high frequencies and they are used for long distance communications. Now we have different types of modulation. There are a number of types of modulation techniques which are summarized in this graph. First is the continuous wave modulation or analog modulation. The other is the pulse digital modulation. The analog modulation is divided into amplitude and angular modulation. The angular modulation is further divided into frequency modulation and phase modulation. This part we have covered in analog communication, which is the subject in 4th semester. And in 5th semester we cover the digital part, the right hand side portion of this graph. The pulse digital modulation is of two types, digital modulation and analog modulation. The digital modulation is basically called as pulse code modulation. whereas the analog modulation is of three types: pulse amplitude, pulse duration, and pulse position. So all this we are going to cover in our next sections or next videos. So for this video I would like to wind up now. Thank you so much.